I'm Professor Rad, and this is Precalc video 317, F-angle formulas. In this video, we're going to be rounding out the two videos plus this one of new formulas and identities for our trig functions. So 2 videos ago, we looked at sum and difference formulas. In the last video, we looked at double angle formulas. So now we're going to look at half angle formulas. As with those 2 previous videos, we're also going to be looking at 2 examples of applying the half angle formulas to give us a sense of, how to use these and how they function. So one thing that's kind of strange about our half angle formulas is that they're not totally specific. So for example, notice that we have sine of theta over 2 is either plus or minus a square root. So whether we get a plus or whether we get a minus is going to depend on where theta over 2 ends up landing. So we are going to have to try and keep track of where theta lives and where half of theta is going to land us. The sine and cosine formulas for half of theta are very similar. Sine, you have 1 subtracting cos theta, and for cosine, you have 1 plus cos theta. So you could try to remember that as sine, it's 1 subtracting cosine, and for cosine, it's 1 plus cosine. And then they're both over 2 under this radical. One of the other things about this formula is that our answers are going to be kind of funky looking, kind of messy. So we're going to simplify to a certain extent, but we're not going to be too precious about our answer being totally simplified. For tangent of a half angle, now we have options actually, because for tangent of theta over 2, we have either 1 minus cosine over sine, or we have sine over 1 plus cosine. So you get to pick whichever one's going to be easier or better for you to use in the moment. Usually the way that I choose which of these 2 I'm going to use is based on whether sine or cosine has a radical. So like if cosine is like √5 in the numerator, but sine doesn't have a radical, then I'm going to use this one because that's going to keep the radical in the numerator of the fraction and make it easier to simplify. Whereas this one would put a radical in the denominator, and then that's messier. So that's not like, a hard and fast rule. It's just a guideline to go by. So let's go ahead and get started with one example of using a half angle formula. Alrighty, for our first example, we need to find cosine of 7 pi 12ths. So we saw this exact example when we did the sum and difference formulas. So we used a sum to help us find cosine of 7 pi 12ths. Now we're going to use a half angle formula and see if we get the same answer, or maybe a different format of the same answer. So when you have a particular angle, remember our goal is to rewrite this angle in terms of angles we know about. So we know about integer multiples of pi, we know about pi halves, pi thirds, pi fourths, and pi sixths. So a half angle formula is going to be helpful here because cosine of 7 pi over 12 is the same as cosine of 1/2 times 7 pi over 12 over 6. Excuse me here. So this is because 1 times 7 pi gives us that 7 pi, and then 2 times 6 gives us that 12. So if you have a denominator and you divide it by 2 and it's one of the ones we know about, then that's a good indication that we want to use a half angle formula. So for instance, if we had something with like pi 8ths, that would also be a good one because you could write pi over 8 as 1/2 times pi over 4, and we know stuff about pi over 4. So let's go ahead and apply the half angle formula here. Now in the formulas, we have cosine of theta over 2, but another way of writing theta over 2 would be to write it as 1/2 times theta, right? So half of theta is the same as theta over 2. So when we go to insert the values into our formula, this is theta that we're going to be using. So we have half of theta. So the half angle formula for cosine is going to be plus or minus the square root. Now sine is subtract, so cosine's got to be add. So combine maybe, I don't know. So we're going to add 1 plus cosine of theta over 2. And then here we've got 7 pi over 6. That's what I'm putting in for theta. Oh, this should be cosine. Got my argument here. So this is going to be cosine of theta over 2. Sorry about that. So we're going to get plus or minus the square root of 1 plus cosine of 7 pi over 6 over 2. Now I just have to figure out what is cosine of 7 pi over 6. So I'm going to draw my little unit circle. And I'm going to break it up into sixths. So here's 1, 2, 3, 4, 5, 6, 7. So it looks like at 7 pi over 6, I'm going to be at negative root 3 over 2, negative 1/2. So that means that cosine of 7 pi over 6 is negative root 3 over 2. So this is plus or minus the square root of 1 minus root 3 over 2 all over 2. Now this is where I was mentioning we're not going to get super precious about simplifying the radical, but we are going to try and make it as neat as we can. So for example, let's simplify this complex fraction by multiplying the top and bottom both by 2. So that's going to give us plus or minus the square root of 2 minus root 3 over 4. And because 4 is a perfect square, we can reduce this one level down and write this as plus or minus the square root of 2 minus root 3 all over 2. So we're almost done, but this would be the extent to which I'm going to expect you to simplify the radicals. So we can just leave it in this format, that'll be fine. What we do need to figure out though is whether we want the plus or the minus. So to figure that out, you're going to go to this angle here, 7 pi over 12. Now, when I'm thinking of dividing my unit circle up based off of pi 12ths, here's how I think about it. Here we have 0 pi over 12ths. Here we have pi, and pi is the same as 12 pi over 12. I'm choosing 12 here because I'm using 12ths. Half of that, so half of the numerator is 6. So this line here is 6 pi over 12. So I'm basically indexing my quadrant in terms of pi 12ths, so that if this is where 6 pi 12ths is, and this is where 12 pi 12ths is, 7 pi 12ths is going to be somewhere over here. So cosine of 7 pi 12ths is going to land us in the second quadrant where cosine is negative. So we want the negative radical. So we get cosine of 7 pi over 12 is negative square root of 2 minus root 3 all over 4. Now, this isn't exactly the same answer we got when we used the sum formula. So digging back through my notes here, what did we get? We got root 2 minus root 6 all over 4. So if we threw these both into a calculator, we would end up getting the same answer. So it does work out, and this would serve as a proof that this value is equal to this one here, in case you wanted to do a proof for that. Okay, let's do another example of using a half angle formula, just so we can practice that a little bit more. In our second example, we need to find tangent of theta over 2 when we know that sine of theta is a negative 5/13 and cosine of theta is less than 0. So the first thing I'm going to do is orient where this angle is living. So sine is negative, so that means we're living in the bottom hemisphere. And cosine is less than 0, so that means we're living in the west. So that means we must be in quadrant 3. So this is where theta lives, not necessarily theta over 2. right? Most likely not theta over 2. But this is where theta lives. To find tangent of theta over 2, I'm going to need a formula for tangent of half an angle. So on this one, it really is going to matter too much which one we choose to use. So let's just jot them both down. We have tangent of theta over 2 is equal to 1 minus cosine theta over sine theta. Or we could write that as sine theta over 1 plus cosine theta. Now, in this case, this is sort of what I was referencing before. I know that sine does not have a radical in it. It's a nice fraction, -5/13. So let's go ahead and plan to use this top one, just in case cosine does have a radical. It's possible cosine doesn't, but we can go ahead and use this top one because we know sine doesn't. So speaking of, we do need to find cosine. So let's use a Pythagorean identity to find cosine. So we know that cosine squared plus sine squared is 1. So cosine squared theta plus 25 over 169 is 1. Just went ahead and I squared sine of theta right there. So cosine squared theta is going to be 144 over 169. So when I subtract 25 over 169, I get 144 for the numerator. So that means that cosine of theta is going to be plus or minus 12/13. So this is a 5/12/13 right triangle that we're looking at. Because cosine is negative, we want the negative fraction. So for this one, it doesn't really matter which one goes in the top or bottom because we don't have a radical. So you get to pick. I'm going to stick to this first one here. So now we can plug in tangent of theta over 2 is going to be 1 minus a -12/13. So that's a plus over sine of theta, which is -5/13. As before, I'm going to multiply the top and bottom by the denominator of 13 to eliminate those little fractions. And that will give me 13 plus 12 over -5. So this gives me 25 over -5, which is -5. So there we go. Now, as I mentioned before, remember that theta and theta over 2 are not necessarily, in fact, they're probably not unless theta is less than 90 degrees in the same quadrant. So here, even though tangent of theta, if this is where theta was, even though tangent of theta could be positive, tangent of half theta could be, in this case, it's going to be in quadrant 2 because we ended up with a negative. So half of the angle, you can end up with a negative value. So remember, you want to try and keep theta versus theta halves separate, right? Because one, just because one is positive or negative doesn't mean that the other one has to be. So that's where we're going to stop for this video on the half angle formulas. I hope you found it helpful. In the next video, we're going to start to undo trig functions a little bit. So we're going to take a look at figuring out angles based off of trig expressions and trying to undo a trig expression. So we'll see how that goes. In the meantime, I hope you found this video helpful and I hope you have a wonderful day. Bye for now.